Welcome, everybody. I would like to introduce our today's speaker, Konrad Talmont-Kaminski, who is a philosopher and sociologist, which is a cognitive scientist, and it's not a typical person who won't be lecture at our seminar, but I hope it will be interesting anyway. So let me introduce Konrad. Konrad is PhD in philosophy of science in Australia at Monash University under the supervision of John Bigelow. Now he's working on cognitive science of religion, sociology of religion, and philosophy of science. And he's employed at the University of Białystok at the Society and Cognition Unit. So the idea is that, so Konrad, you have more or less 50 minutes or so, then we'll have 10 minutes of questions. And after that, we'll go upstairs. We'll be able to talk to our lecture today. We also plan to go for and also plan to go for lunch after that. Cool. So the floor is yours.
Thank you. Thank you very much for the invitation. The fact that I'm willing to talk to an audience of physicists, not being a physicist, shows that I'm either brave or stupid. I leave the judgment up to you.
Oh, brilliant.
I leave out the possibility, seriously. But anyway, I wanted to start off with a photo which shows what I look like when I reach the very heights of my knowledge of physics. That's what I look like. I'm the one on the right. Okay, that's my final year of high school. Yes, I read high school physics, and that's all the physics I know. So ahead of time, I apologize if I say anything that is anathema to physicists. Please just point it out and lead me to the right path. Okay, so given that I know so little about physics, I want us to start off talking about something different. Easy. Okay? Imagine the following. All right? Imagine that you have to study a field where the things that you want to study have the following properties. Okay? So in this field, every single particle is different. It's not like you have electrons that are fundamentally the same and neutrons that are fundamentally the same. They're all completely different. Well, completely. You don't even know, right? They're very different. They're very different. What's more, they all have lots and lots of properties, and you don't know how many of those properties there are. You don't know which ones are fundamental, which are just kind of phenomenal. They're all also constantly changing. Right? No spoilers, no spoilers. Right? And also, these particles, they're all very much, the properties are very much connected to each other. What's more, right? The particles are constantly interacting with each other. And there are lots and lots of different kinds of interactions. Constantly new ones are appearing. And we don't really know what all those different kinds of interactions are. Imagine having to deal with something like that. Right? So that's what I wanted to start off with. And here's an example of the kinds of interactions these kinds of particles get into. Right? Of course, yes. As one of your colleagues pointed out, spoilers, I am talking about sociology. Right? Now, of course, that's an artist's rendering. Let's do a real picture of an interaction of these kinds of particles. There you go. That's a real picture of interaction of these particles. Sorry? Yeah, I'm not sure. One of them. So let's, seeing that I'm coming from the social sciences, let's talk a little bit about the history of all this, right? This gentleman here, looking very quizzical, is Wilhelm Dilthey. I'm never sure about the pronunciation of his surname. I don't think I've ever heard it pronounced. I've only ever seen it written. right? So this gentleman is a very significant philosopher of science, you'd say, I suppose, from the second half of the 19th century. And one of the things that he's very much known for is that he talked about there being a fundamental distinction between what he called the Naturwissenschaften. Please pardon my German, I don't speak the language, which are, of course, the natural sciences. And then, on the other hand, the Geisteswissenschaften, the human sciences, right? The sciences of the ghost, which kind of puts you on the path of what he was getting at. I mean, he himself didn't have a particularly religious outlook, but was definitely informed by that. So he thought that these two sciences had a very, very different nature to them, but it has to be said, he did think that the Geisteswissenschaften could be a thing, could exist, right? Which is far from something that everybody at his time, or even later, would agree with, right? So one of the things that he pointed to when it comes to the study of humans is the significance of history, right? Just earlier we had a conversation about the significance of culture, right? Which of course is a carrier of certain aspects of history, right? So yes, absolutely fundamental to understanding human beings. But of course, when we hear that these days, I hope that a lot of us immediately go, but hold on, there are natural sciences where history is fundamental, right? I'm talking about, obviously, life sciences, right? So it's not actually as straightforward as it would have seemed in his time. Already we see that. Also, what he said, and this was really a very important kind of distinction that was made between the Naturwissenschaften and Geisteswissenschaften, was that where in the natural sciences you get explanation of natural phenomena, in the sciences of the humans, all you can hope for is reaching understanding and interpretation, not explanation. And I would add to that, not prediction. Right? So this distinction that he made was very important throughout much of the 20th century. In fact, a lot of people who focused on this distinction thought that he wasn't radical enough in what he was saying. Right? The scope for sciences of the human were far more constrained than what he considered possible. Right? And on the other hand, he's also had something of a bad press because of making this distinction and then making it sound like sciences of the human, well, are kind of mysterious and somewhat obscurantism, perhaps, right?
Or maybe spiritual.
Spiritual, exactly, of course, follow that, right? But I think we really have to consider the context he was writing and thinking in, right? Let's think back to the second half of the 19th century. What situation was that, right? In this room, people should know who this was.
New York.
Rutherford, yes, of course, Rutherford, right? Rutherford, born about, I think about 40 years after Dilthey, but very much covering a similar period, right? So in the natural sciences, what you've got is people like Rutherford doing their work. You've got, of course, Newtonian physics being all important and fundamental at that stage, far more than it is now, of course. This was a mature science, which was highly effective, right? On the other hand, when you look at what was being done in science, in the social sciences, what are we talking about? We're talking about stuff like the pseudo-Darwinism of Herbert Spencer. Right? Who here has read Herbert Spencer? Yeah, exactly. Nobody here has read Spencer, and there's a very good reason for that. It's garbage. Okay? The scientific terms for that are a lot more complex and require a lot more explanation, but fundamentally, yeah. Right? The theories that he put forward are not part of anything in sociology really these days. Right? You've got that, you've got Freudian psychology. Right? People who most like to read Freudian psychology these days are philosophers who don't know psychology. Right?
I think Young is much more appreciated than Freud. I don't
Not by me. Yeah, I have to say. But yeah, I think that is probably correct. Yes.
I don't want to interrupt, but I read some articles by contemporary psychologists and also science philosophists, experts that nowadays Freud would be probably perceived as a pseudoscientist because
Well, if he was doing his work right now, that is exactly what he would be considered. Absolutely.
but not 100 years ago, of course.
Yeah. Again, history, right? Yeah. I mean, you can't say that he wasn't a scientist in his period. There's no reason to meet him today as a scientist, right? But also, in that period, you already have Emil Durkheim writing on religion, where actually his work, there's a lot of stuff in that which is actually really quite useful to people who study religion. Although I'm one of them, right? But still, you see that there was this really striking difference between these different kinds of sciences, right? So I really do think that Dilthey was quite justified in what he was saying. In fact, he was quite optimistic. You could even say positivist to think that you could have a science of the human, right? But when he was making these claims about what the relationship is between sciences, the natural sciences, and the human sciences, I think the question that comes into play here is one which comes whenever we talk about scientific theory, because his theory, in effect, was also a scientific theory. It was a theory about science, right? And fundamental question for any scientific theory is, what's the scope of the theory? Well, a fundamental question. It's not the fundamental, it's well, a fundamental question, right? So what was the scope of this distinction he was making? It made sense in his time, right? But I want to show you guys something to do with what I do, right? Those of you who are from Poland will have heard of the JP2 generation, right? This is a hypothesis which was put forward, well, hypothesis is maybe too strong a word, but it was an idea which was put forward around the time of the death of the Pope. When you say the Pope in Poland, of course, you mean John Paul II, right? Which was 2005, if I remember that correctly? Yeah. Okay, right. So the theory was that his death had such an effect on Polish society that you would see a return to religion by the younger generations. Okay, so here's some data from the Central Bureau of Statistics from 2018, so 13 years later. This is attendance, church attendance by cohort, by age cohort, right? So you've got obviously the people who attend the most, 75-year-olds and older, and it goes down to the 25 to 34-year-olds, where you have the least number, and then it jumps up for the group between 16 and 24.
Well, maybe they go with their parents, right?
Sorry?
Maybe they go to the church with their parents.
Spoiler again. Right? Yes, right? That is part of the explanation, but you can see why some Polish sociologists looked at this and went, hey, JP2 generation, there you go, return to religion, you've got essentially a single data point here, Poland in 2018, right? What about at other times? What about in other secularizing societies? Guess what? Exactly the same thing, right? When you look at other times, other places, you see the same pattern, where the youngest generation is more religious. Sorry, the youngest cohort is more religious than the slightly older cohort. The reasons why? Well, partly because they may be going there with church with their parents, but fundamentally, what we see is the process of secularization is tied with the process of socialization, right? So after 25, most people, their religiosity stays the same, right? So also, these people who are 75 here, they were attending church as much when they were 25. It's not that they started to attend church more as they got older. There are societies where this is different, but fundamentally, this is the situation in most societies, definitely the situation in Poland, right? Insofar as we have data. We have data going back to the 80s. Okay? So, as I said, a single data point which people interpret in a particular way because they weren't really thinking in terms of what is the scope of the theory, right? But, I'm picking on the social sciences, but, I mean, let's think about these standard examples from physics, right? At the time of Dilthey, people would have thought that Newtonian physics describes all physical interactions. We don't think that anymore, right? I did get that right?
Not all regimes.
Something about that. I don't want to get into any scientific discussions of modern physics here.
We can maybe say that there are systems which Newtonian physics will break down, and then you need to use Einstein physics to have a better description. But in general, they describe the same phenomenon, gravity. But there are systems or regimes when Newtonian physics is not applicable anymore. So you can take it away to the sociology if you like.
Thank you. I'll go back to my own field.
I think already at the time of Dilthey, we had we were suspicious about Newtonian physics because we actually thought them. They were weird things.
My background in philosophy of science means that I get really picky about the logical arguments. But the historical stuff, I kind of let slip sometimes. Yeah, of course. Yeah. I mean, it's never as simple as how we describe. Yeah. All right. The example that I absolutely love, right, is August Comte on the chemical makeup of distant stars. Do you guys know this example?
I think I've heard this once.
Right. So August Comte, the most amazing positivist at the beginning of the 19th century, this is about 1830, wrote that we will never know the chemical makeup of the distant stars, right? There are questions that science will never answer. And looking at the methodology that was available to science at that time, yeah, that made sense, right? We weren't about to rocket off to a distant star, grab a sample and find out what it's made of. Within, I think, 20 years, we were able to do it by looking at the spectra, right? The thing that I always tell my students about is the amazing thing that these days we're getting to the point where we can tell if there is life on the planets orbiting those stars by looking at the light which goes through the atmospheres of those planets.
That's very positive take, but yeah, we're getting there.
Getting there. I'm always an optimist.
But it's not impossible.
It's not impossible, right? It's a question of technology. We're getting there, right? So basically, what I'm getting at is this question of scope is a universal problem, right? Dilthey overestimated, same as, in a sense, Comte overestimated his hypothesis. It was appropriate to his time, to his methodologies, so on and so forth. Things change, right? And of course, this kind of issue is going to be particularly important in the human sciences, as I think the example of the JP2 generation hopefully showed, right? So, how do we think about this? Right? Often science is contrasted with crafts, right? But I like to think of science as a craft. I like to think of scientists as craftspeople, right? This is why I have this picture here, which could possibly be a painting of Robert Hooke. We don't know, because we don't know if he had any paintings of Robert Hooke.
You can burn them.
That is the hypothesis. Yes, that is indeed the hypothesis, right? Robert Hooke, of course, is famous for having designed a whole bunch of experimental equipment, right? And having come up from a background, from a family of craftspeople, right? So for me, he's a great example of this kind of thing, right? So one of the things to be said is that there's no such thing fundamentally that's worthwhile describing as the scientific method, right? Now, this might be strange and difficult for some people, but work with me on this, okay? This is a good thing. This is a good thing, that there's no such thing as a scientific method. Why? Because this means that there are no such things as limits to scientific method. Right? When people say that there are things that humans can know that science cannot come to grips with, I call them on this and say, why? Why can't science include whatever methods are the ones that work to investigate whatever it is that you're interested in? Right? This is the thing, right? It's a craft. Whatever works, you use it. Right? One of the fundamental things about science to me is that it's extremely important to keep developing novel methods, right? You find a new question, a new kind of phenomenon that you don't have the right methods to study, you invent new ones to study that, right? And of course, when we talk about scientific method, we're talking about using logic, using experiments, using mathematics, and so on and so forth. Yeah, that stuff works, right? It also works in lots of other areas, not just in science, right? And it's not a coincidence that it does. It's just the kind of universe we live in, where this kind of stuff works to understand how the universe that we live in works, right? So the other side of that is that whatever material you're working with, the methods that you use have to fit that material, right? Whatever phenomena you're studying, the methods you use have to fit that phenomena, right? So if you study social phenomena, you have to have methods that fit those phenomena. Right? So, insofar as Dilthey was saying there's going to be a difference between the human sciences and the natural sciences, there's obviously going to be something right about that, right? Because it's a different subject matter, so some of the methods are going to be somewhat different, right? Because it is a life science, I think. A social science is a life science. A lot of the stuff from biology will carry over, right? I think evolutionary explanations for human behavior are great explanations. Yeah.
Yeah, I don't want to interrupt again because I want to force my time, but I think I would like to challenge you here a little bit. The way we physicists approach to scientific method is not a specific methodology, it's more like a description of the main properties that any algorithm will need to have in order to be accepted to bring scientific proof.
Mm-hmm.
So this is either induction and deduction. So induction means many different observations you can generalize over to find a property of a system.
Mm-hmm.
Deduction, if you can find logical connections between the one property to the other, and finally reproducibility. So this three makes us a general scientific method algorithm properties. This means that other groups can replicate your observation and get to the same conclusions. It has nothing to do with particular methodology you want to use, right? I know that you went over the story that previously we know the science didn't have limits, and some people thought we're never going to learn chemical history of the stars, so on and so forth. And I fully agree that the particular implementation of this for human sciences will be definitely different than for natural sciences. But I think there is a scientific method. There's something that allows us to gather the evidence despite the human flaws.
Okay, right. if you make the description general enough, you'll be able to describe something that is, you could call scientific method, right? But it's not particularly useful, especially specifically for science. I mean, these things you have to care about if you just want to know about the world, right? Instead of ignoring it. That's one thing to be said. Another thing to be said, when it comes to induction, we don't actually have a good understanding of what the hell induction is and how the hell it works, right? We're trying to come to grips with it. It certainly works, whatever the hell it is, right? So, you know, the other side of that is we don't know what method it is exactly that we're using, right? There are various mathematical things that we use, Bayesian statistics and so on and so forth, right? But as a general description, we don't even have a good general description of what we're trying to do here, right?
And particularly at the beginning, we frequently have something which is a good guess. And that is really difficult to quantify in any way. This good guess.
But you don't know this good guesses, Bożena, right?
Well, but it's my starting point, right?
My favorite cartoon about scientific method, I'm sure most of you here are familiar. There's this guy standing there, he's thinking, you can see he's thinking very hard. And suddenly he's smiling. And then this much bigger guy stands up behind him with his data on the guy, and he's saying, no.
Yeah.
And the guy is back to thinking very hard, right? At a certain level of description, that's what it bloody well comes down to, right? All right, so let's have a look at social phenomena, right? So as I said, we have this extremely high level of complexity, which has made studying this so very, very difficult. It has meant that the social sciences have lagged behind a lot of the other sciences, especially sciences such as physics, right? I mean, here I am, somebody working in social sciences, saying that the social sciences are behind physics. Don't let my colleagues in sociology know about me saying this, okay? I hope this isn't going out on the internet or anything like that, right? So yeah, I mean, this is the case both at the individual level and at the societal level, right? We've got, as I said previously, extremely high levels of complexity here. So historically, what we've been doing is we've really been abstracting away from a lot of the complexity in any kind of description of this, which has been highly problematic, right? Because you get all kinds of interactions happening here that really we're finding out more and more are fundamental to understanding what's going on, right? So our models have been really poor, right? Also, we've been, I think, been affected by what we could call folk sociology. I mean, there's also folk physics, right? These are the sort of intuitive ideas that people have about how physics works, right? If you push something, it'll move for a little while and then it'll stop, right? That's what happens in physics, right? Not quite, not necessarily, right? Well, I mean, think about folk sociology. Look at these two people here, right? We look at them and we immediately formulate hypotheses about these people, right? We look at them, okay, they're standing very close, they're probably married, right? They look old, they look rural, they're probably conservative, right? You can hypothesize lots and
Pitchfork
lots.
adds to the conservatism.
Sorry?
The pitchfork adds to the conservatism.
Yes, he's probably got his daughter or something like that, right? Stereotypically. So yeah, actually probably granddaughter, given the time and the age, right? He's probably more than 40, even though this was a while ago. So we've got this lots of intuitive knowledge about social phenomena, which is actually extremely useful to us. I mean, it is fundamental to us being able to function, right? Anybody who looks at the kinds of difficulties of people who are high on the autism scale, who lack a lot of this folk sociology, can see how important it is to our normal functioning and how they have to make do using other approaches, right? But when we're trying to do science, folk sociology is as much a boon as it is a curse, right? Because we don't develop good ideas, we develop bad ideas, right? Quite often, actually, right?
More often than.
And the thing is that these assumptions are shared, right? The folk sociology we have is very similar among different people, right? And this is another point that I want to make, right? Because of how am I doing for time?
You have
Another 10 minutes.
20 minutes for example, so.
Okay, good, fine. You
By
get,
false sociology, you mean prejudice, basically.
sorry?
You mean prejudices by false sociology by modern standard, or this is something more than just
More than that, right?
Bias.
I mean, you know, we have an intuitive understanding of social interactions, right? The hypotheses we make here, I suspect, probably largely correct about these people, right? I often like to show my students just pictures of, for example, a boardroom, right? We have a bunch of stiff-necked looking, you know, characters there in suits, and I'm saying, okay, what are they feeling? What kind of social situation is this? Who is most important? What are their, you know, what are their relations? A lot of information people immediately get. They don't even realize they get this information, right? Because we're good at this. We have to be, because otherwise we wouldn't be able to live in society, right? But because they're shared assumptions, and this is very important, I think, it's very difficult for us to see beyond them, right? One of the things that I love telling people about is the history of primatology, right? In early 20th century, mid 20th century, you had primatologists with names like John, like Henry, like Richard, talking about how when it comes to sexual selection in primates, the males are active and the females are passive. And this was the hypothesis, right? And then you had a bunch of other primatologists come along with names like Jane and Sarah and say, guys, are you blind? And fundamentally, yeah, shared assumptions, blind to certain phenomena, right? And because we're all damn humans,
confirmation bias.
right? So, especially when it comes to social sciences, because of this, diversity is absolutely essential, right? I'm in a project right now where we're trying to model small-scale cooperation, and we're all guys in the group, and I feel very uncomfortable about that. I mean, there's obviously equity, but there's also competence here, right? But we're all going to be always humans. Well, maybe not, right? We've got artificial intelligence coming along, we'll see how that happens. We're going to talk about that. But that leads to shared assumptions. All right. So another issue when studying social phenomena, right? So I want to talk about example of this difficulty of having these different theories at different levels describing this extremely complex phenomenon. Right? As I've said, I'm interested in religion, particularly in secularization. Right? And you have in sociology theories about these social phenomena, the social phenomenon, called secularization, and how societies change, and you get this massive change in those societies. And then also in psychology, we have theories about why particular individuals become less religious, become perhaps atheists, right? And there's a fundamental issue here, because the psychological theories are not very good at explaining why you would get this massive social change, whereas the sociological hypotheses, theories, are not very good at understanding what is going to be happening at the individual level within that massive pattern of change. right? But obviously, those two things are just different aspects of the same damn phenomenon, right? So you really want to integrate those theories, right? The problem being that this is beyond what normal human cognitive ability allows us to do, right? This is far too complex for us to be able to do, right? It's also even beyond simple mathematical models, right?
It's the first time you use the word mathematical. It seems to me it's very strange. You speak about science, but the word mathematical, it's the first time I see.
Yes. When I talk about what people in my research group can do, right? I will say, okay, so this is Łukasz and Piotrek, for example, they're really good at data science. They're really good at statistical models and so on and so forth. This is Ivan. He's great actually modeling, building the models, coding the models, and so on and so forth. And when it comes to me, I kind of go, well, what am I good at? I don't know, talking to all these people, right? So there's a reason why I haven't said that much about mathematics, because the last time I did mathematics was about 2 years later than that photo I showed, second year mathematics at university, right? And that was about as long ago as I've done mathematics. So I'm trying to stay the hell away from the details, right? If somebody shows me statistical analyses and explains them to me, I kind of understand what they're getting at. I understand the significance of effect size of sample size and so on and so forth. But yeah, I'm not an expert by any means. So yeah, there is a reason why I've stayed away from the word mathematical, even though, of course, yes, right? Something that I also say, if I was to do a university degree again now, I would take all the statistics, because I feel fundamentally crippled by not having that. Okay? All right. So yes, you have to be able to include complexity and diversity of the individual. You have to then generate those patterns of change at the social level from those individual level interactions to then really properly integrate those theories. But as I said, this is not something that normal human cognitive ability allows us to do. Right? When I talk to my students about this kind of thing, I talk about, imagine a pile of rocks, right? And how a pile of rocks behaves, right? The behavior of a pile of rocks depends to a great degree on the shape of those individual rocks, right? If you want to understand how the whole pile behaves, to a great degree, you have to take into account. And of course, with human beings, it's far, far more complex, right?
Well, as a physicist, I would also challenge you here, saying that we could probably describe some average properties and distribution of these properties in the pile of rock and try to predict stability, for example. So there are some ways you can do without having knowledge of every single rock.
You can go some
I
ways.
agree that.
Yes. I mean, you can go some ways by abstracting away from this in the social sciences. But in the social sciences, it's not as far as you can go in physics.
It's more dangerous, yes,
Yeah.
social sciences.
In social sciences, you have additionally this feedback. So
Yes, you do. Yeah.
stone can talk to stone and then make a decision because of the third one, or they heard something.
No,
or
but
what.
it's harder to make experiments in social sciences because of the ethical reasons and the scale.
Exactly.
Well,
Right?
but in astronomy, we also have to make experiments. We have to look at what we can see, and that's really quite.
Yes. Yeah. All right. So all of this really is leading me towards what I think is an absolutely crucial recent change within the social sciences, which is the appearance of agent-based models. Right? Now, these models, they are formal models which exist in a computer, right? They are descriptions of these phenomena which are coded into a computer, where, because of that, they're not limited by limits of human cognition, right? Among other things, once you make a model of any phenomenon. You can rerun it millions of times to then derive those probabilities that we just heard about, right? And you can actually describe those stones at the level of individual stone, because what you do is you begin with models of those individuals in those societies. Now, sometimes you'll have better information about those individuals, sometimes worse, and that will be a fundamental issue. Sometimes you'll have a better idea of what variables are important, and sometimes the worst one. That's also an issue, right? This isn't magic, right? But it allows you to move forward with dealing with this kind of complexity, right? Right? Then you look at the interactions between those individuals, and out of that, you get patterns of social change, where you can look at those patterns in the model and say, well, actually, that's not what reality looks like. So clearly, the assumptions were wrong. Or not, right? But it really allows you to move forward to a great degree that previously was not possible. So what am I talking about, right? I mean, the traditional approach in sociology, you have different groups of people, they interact with each other, right? That's what reality is like. Reality is like this. You get people who are all different, and they interact with each other, right? So the novel approach here is, as I said, you start out with a model of an individual agent, an individual human being, which is going to be based on psychological theories and data, better or worse, right? And then out of these agents, you build all societies, which have an analogous structure and dynamics to reality, right? And there, of course, you apply sociological theories and data. Okay, so that's the basic idea here. Now, as part of my work, I actually did an agent-based model of secularization with my colleagues, of course, not I. I don't know how to model, right? A lot of the fundamental competences that are necessary, I do not have, right? So with my colleagues, we did an ABM of secularization during the 20th century. We looked at potential causes of secularization, right? Basically four: appearance of pluralism in society, religious freedom, rise of education, and security, what's known as existential security in the sociological.
So this would be wealth?
No, I mean, wealth is part of it, but not quite, right? Because I mean, you can have very wealthy societies, like the United States has been, where levels of existential security was relatively low, right? No, we're talking about, you go out in the evening and you're not worried you're going to get mad. You get sick and you're not worried that you're not going to be able to go to hospital and be taken care of. You get sick and perhaps die, you're not worried that your kids are not going to have the social support to be able to grow up properly, right? Those kinds of things. So to a great degree, what kind of stuff the welfare state provides, right? So we looked at those kinds of potential causes, and we, in the model, able to put them all into the model and then turn them on or off within the model and see what those model societies look like, right? So I'm just going to show you guys one picture, right? This is Poland during the 20th century, okay? There are three groups here. These are the profoundly religious. These are the completely secularized, and these are what's known as the fuzzies. Fuzzies, in other words, these are the people in Poland, typically, that would say, are you Catholic? Yes, of course I'm a Catholic. When did you last go to church? Uncle Stephen's funeral was back in January. I think it was Uncle's. You get the picture, right? Another way to be fuzzy is to say, no, I don't believe in God. I believe in the universal spirit. Or something like that, right? Lots of different ways to be fuzzy. You've got this pattern, this is the observed data from Poland, that we've got, these are different cohorts, right? And these dots here are different models of Poland where only existential security was taken into account as a cause of secularization, right? Looks pretty good. This isn't proof perfect, of course not. But this is the kind of thing that can get you. It's able to pull these hypotheses apart, look at them individually, see how they affect the society.
What are the dashed lines here? It's kind of fundamental.
Oh, the dashed lines, this is beginning of where we had, sorry, this is the beginning of the 20th century. This, hold on. Yes, this is the beginning of the 20th century. This is 20. This is last cohort from round about 2000 that we have data from.
I'm asking not for the sake of asking, I just realized that your secularization prediction was really bad until
Yes,
crossed the dashed
yeah,
line.
we are concerned about that, right? Yeah, absolutely, yes. Mea culpa, maxima culpa, yes, right.
So you mean that this data goes back to basically the early 20th century?
Yes, it does. The way it can do that, okay, the way it can do that is because obviously we didn't have data gathering about people's religiosity at the beginning of the 20th century. But these people, some of them are still alive in the 1980s when we did have the data gathering. And because we have the hypothesis that the religiosity doesn't change over the lifetime after 25 years of age, which has been borne out by lots of data from lots of countries, we're able to project it backwards.
Okay, you're missing one very important factor.
Yes.
The view of the Jewish minority.
Yeah.
Which was also divided to religious and not religious part.
Okay, so this is Poland without the Jewish minority.
Okay,
Yes,
that's all.
absolutely. I mean, look, there are lots of issues, right? One of the things that we did was for existential security, the measure that we used as indicative of that was childhood mortality, which changed dramatically over the 20th century. Now in Poland, there's a fundamental problem with that measure. There are two periods for which we have no data. 1418, 39, 45. Were they similar to the other periods? Oh, hell no. We know they weren't. Right? They were fundamentally different, but we don't know what they were. Right? So there are a number of different issues. The fundamental change in the Polish population from the earlier 20th century, the disappearance of millions of people, that's another issue. Yes, absolutely, yes. Right? The good news is we've also done this for Norway. Norway didn't have those issues. We get very similar result from Norway. I'm showing the Polish result here because, well, we're involved. Okay?
Sorry, can I ask?
Yeah.
Yeah, the topic of complexity, because like there are different countries in the world, different situations, like
Yes.
where you have reverse of secularization somehow, like Brazil or somehow maybe South Korea, right? And
Not really. Right. The one
Okay.
country where we do see a pattern of long-term growth of religiosity, really, in the data that we've seen, is Israel.
Okay.
Okay.
And then your model, like does how it works?
I think actually Israel works very nicely. We haven't modeled Israel, but I can give you an explanation why Israel is going in the other direction. It's been fundamentally in a state of war since its creation.
Yeah, let's say as a scientist, I'm more interested than maybe model, like how model works, an explanation.
Yeah. As I said, we have not modeled Israel. Yeah. There is way more to be done, of course, right? All right, so last slide, okay? So what will this mature social science look like that I'm hoping that we're going to get, right? Well, first of all, I really hope that we're going to get past this, I think, fundamentally unhelpful discussion of whether it is possible to explain human behavior, right? I come from the, I think, very much justifiable assumption that human behavior is a natural phenomenon, and it is just as explainable as any other natural phenomenon. It's just more difficult, right? Very much integration with life sciences. You're seeing a lot of evolutionary explanations of human behavior becoming more and more important. Continuing development of methods of data gathering. Yeah.
What do you mean by life science?
What do I mean life sciences? Well, I mean, I suppose the shorthand would be biology, right? Especially evolutionary biology, right? So humans are a species, right? If you want to understand our behavior, one of the best ways to understand our behavior is to look at the behavior of our closest cousins, right? You want to understand what the evolutionary pressures were that shaped behavior that we have. What were the functions? Those kinds of things, right? Okay. Focus upon the integration of those theories in formal models, right? Agent-based models. Accurate prediction of social change. And I want you to notice, if we have accurate prediction of social change, we have the possibility, the scope for, I would say, the unavoidable future of social engineering. Yeah. Happy? Not
In the
happy?
era of social media, it's already not a potential, it's already a thing.
Exactly, right? I mean, this is
But without
happening. We have to understand what's happening. You know, and you remember the photo I showed right at the beginning of me when I was finishing high school. At the time, I was reading something which, doing this work, has really brought me back to it. Do people recognize these covers? I'm wondering, anybody? Isaac Asimov Foundation. Because fundamentally, that's what it comes down to, right? If you know the Foundation trilogy and how he talks about the science of predicting social change, that's fundamentally what we're getting to. I think.
The covers the book had were published in the People's Polish Republic or
Of course, yes, of course they were. Sorry, for me, these are the standard covers of the Foundation trilogy, right?
Nowy Cup, Krajowa Agencja Wydawnicza, so was for me.
Right, of course. All right, so that's it from me. I have talked longer than I thought I would, but we still have a few minutes.
We still have 8 minutes for questions. So first, I would like to ask if there are any questions from the audience who are listening to us remotely.
Should we take the speaker first?
Oh, yes.
No, I'm doing it. I gave a talk at the Konrad Lorenz Institute in Vienna, right? And at the end of my talk, suddenly everybody was doing this. And I was going, what the hell does this mean? Are they saying we loved it? Are they saying get out the door? No idea.
No, Vienna has its own traditions regarding okay, so I don't think there are any questions from the audience. Are there any? No, I didn't see any. So maybe from the audience over here, Professor Jan.
Question or comment, even though you avoided to use the word mathematics, there are some mathematical theories that are, I think, quite well established in the social sciences or economics, such as the game theory. And so, what about that?
Absolutely. I mean, it's actually interesting, right? Because I mean, Brian Spencer's work on the state count, right? That's something that is an example of game theory, and it's something that we use in one of the models that we work with, right? The problem with game theory is that it makes too many assumptions. It's too simplistic for these interactions. So, for example, in the game theory, in the state count like model that we have not just whether you will cooperate with the other hunter, or actually in our model hunters, because we have groups of hunters, but how competent the hunters are, whether you remember, to what degree you remember what they did the previous time they went out hunting. A lot of additional variables which make the model too complex to handle in game theory, requiring agent-based modeling. But the heart of it, yeah, absolutely game theoretic. So, I mean, there are aspects of social phenomena that you can absolutely model using simpler models. But we're trying to get beyond those limitations.
Okay, thank you very much.
about those simple models, they are also impressive. I saw an article about modeling social media and polarization of views. When models started with a group of, let's say, elements and 2 points of view, and then by the feedback, everything divided in short time scale into 2 groups with almost no cross-check, because then every group was reading views which are more consistent with their views. So that the communication really stopped, and it was just modeled on the computer, not in the real social media.
Allow me to
Cross-check.
allow me to work against the grain of much of what I've said. I think we as humans often give ourselves too much in terms of how complex we think we are. I think sometimes we actually are motivated and behave in ways which are a lot more simplistic than we're willing to face. So yeah, there is that too. Look, I mean, what we're talking about is social networks, right? And how social networks look like and how they change and so forth. That's absolutely one of the main elements of trying to build an agent-based model. So sometimes that is sufficient to give us interesting results. Sometimes it is not. Yeah.
Okay, so there was a question from Oliver.
There's actually a comment from Oliver, sorry. So in physics, we have like spectacularly good models of fundamental particles. We have like quantum mechanics, which is wonderful, amazing. But if I want to model like, I don't know, a car, a star or something, we don't use that because we can't. It's insane, it's impossible. We don't build our models out of fundamental models because it's impossible. And so I kind of want to push back on the idea that it's the only and the optimal thing to do is always to break society down into people and model individual people. Because maybe a good thing is to model like groups of people. It's like, it's very important to model at the right level, basically. To get like,
I mean, the short answer is yes. The short answer is yes, right? But I think, again, the history of the social sciences has shown very clearly the limitations that these kinds of theories have. They're not useless by any means, right? I never wanted to claim that. But I think in a lot of cases, you do need to get beyond that. And you have, I think, much more of a scope to do that with the social sciences. There's more of a need, there's more of a possibility of doing that than modeling a car by starting with individual particles. Because first of all, you're talking about actually a much smaller number of particles. Right?
Yeah. Okay. We have time for last question.
Well, definitely, thank you very much for the talk. It was very interesting for me, for sure. 2 versions of questions. So first, agent-based models look to me are very much inspired, or I don't know in which direction we went with the epidemical models, how the pandemic spread. Remember, and we learned a lot about this as a public during the COVID. There was people building this interaction of societies and groups, and will that help them predict pace at which some epidemic will spread? So do you know, is there any inspiration here and or not? And the second question is that I also touching about something Oliver said, that I think what you're doing essentially is like Monte Carlo for sociology, which we sometimes also use a simplified probabilistic model with some constraints for physics. But what we really missing in physics and we struggle with is to model emergent phenomena. So we can really model fundamental reductionist interactions of a system, but sometimes this phenomena that appears only when you reach some critical scale, which you cannot predict a priori. So I think with maybe psychology, you're dealing with something like that as well.
I think, to take the second thing first, I think that, I mean, when it comes to discussion of emergence, right, I think from a sort of philosophy of science point of view, there's a lot of stuff being said there which is just touchy feely nonsense, right? But yes, you do have emergent phenomena, absolutely. And yeah, I do think that, you know, you do have to have these kinds of models to be able to help you with that. Right? I mean, this was kind of the point that I made with the distinction between atheism and secularization and standing two, right? So that's one thing. The second thing is, I can't remember the name of the guy, It's Franciszek Rakowiecki, sorry?
Like from ICM, UwB.
Yes, right. So, I mean, he actually built agent-based models of how COVID would spread in Poland. I talked to him a couple of times about this, right? And those models worked. The problem was nobody in government wanted to listen, right? Which is actually going to be one of the big problems with what I talked about in terms of, predicting social change. Getting people in government to listen, like people, if we use these policies, this is going to be the end result. We can see this. Don't do this. It's actually what Asimov was talking about.
Okay, thank you very much. It's already 1:30. Let's thank the